are you guys? It's Emil. Today we're going to be going over our CAF SAF Web GUI. So this comes out of our structure analyzer featureizer, our compositional analyzer featureizer, as well as the performance metrics that come out of these two. So we've since moved on from the terminal interface. We decided to upload this in a nice web app, and the repository is linked. However, very clear stipulation from the jump. We have some pretty nice documentation. Everything is fine and dandy. So you run it through in your terminal just like this if you're using Mac, otherwise PowerShell if you're using Windows. So once you get all these steps done, I do need to preface this by saying it does require multiple repositories. So what do I mean by that? Well, you go over to these the respective repositories, such as Structure Analyzer Featureizer app, CAF app, and these are all linked here. And you have to install them as well. So when you head over here, you download zip or you open with GitHub Desktop. However you want to do it, just make sure these three are also installed. So what does that look like? Well, it looks a little bit like this. So I have the GUI here. I have compositional analyzer featureizer there, structural somewhere there, and then the performance is here. Otherwise, it won't work. And this is only if you're doing it locally. If you're not doing it locally, I think it's fine because it calls it upon it from the repository. I'm not 100% sure, but for the most part, most people will be doing this locally. Why is that? Well, Heroku times out when you're doing the structural CIFs. So it really can only handle about 10 or 20 very simple CIF files. Otherwise, you'll need to do it locally and follow the installation procedures. So from CAF and SAF, we have all the same features that we were able to do in CAF: filtering, formulas, sorting, compositional features, as well as a structural one from SAF. And we also added a new one-shot method where you do the CAF options that are relevant for the generation of compositional features, which comprise of options 1, 2, 3. And then the generation of the structural featureizers, which is 6. And then it also merges your compositional and your structural features. From there, you just do pretty much, that's all that we're going to do today, is we're going to do options 7 and 8. But we also allowed for the option of CIF file uploads, so we just upload the zip file there. We try to make it very clear cut. We know it's still a little complicated, but we tried to add little notes. If you're using, options 1, 6, 7, should be 6, 7. It should contain CIF files. Maybe you want to do the Excel options, and these come out of our very first version of the CAF SAF terminal. You could include extended features if needed. The default is no. So also important stipulation, when you're doing option 7, if you do option 7, it uses the defaults for every stage. So there's no sort of adjustment there. Otherwise, you'll have to do options 1, options 2, options 3. And when you do them, we know that there's a lot of Excel files that are uploaded. So to sort of mitigate the confusion, we have notes done after each step. It's like, oh, move on to option 2 using this file, so on and so forth. So we're going to just do option 7 here, and I already did these all, but I realized I wasn't recording. So obviously that's a very big rookie mistake on my end. And again, we're just going to upload a folder of CIF files. They all look like this, so it's real, it's real. I'm going to add the zip folder, and these are just compressed. So we'll run option 7, and this will take just a little bit of time. Most amount of time comes from that structure analyzer featureizer. And I believe we do support Pearson's Crystal database, ICSD, and maybe 1 to 2 more databases in terms of the formatted files. I'm not 100% sure. I was trying to check the original documentation from Bob, who's the biggest contributor to this. However, I'm not 100% sure. But anyways, we have the features here, the package APIs, everything's very well documented. Same goes for your structure analyzer featurizer. So it is in the original publication here, as well as SIFKit, which is really the engine of SAF for your coordination environments. So if you guys could feel free to cite these if you found it beneficial by any chance. I'm just going to see. All right, perfect. So this is what we support. PCD, ICSD, COD, and Materials Studio. Now let's check up on our web runner. It's still running. So let that sit. So that's all done. So it's merged, fine. That's all fine and dandy. Then we could run our SAF-CF performance. So a little thing to note. The outputs will be generated right here. So we just unzip them. And now we can get the outputs. We have the matched and the merged. The merged will have all of the features, so that's the one that we're going to focus on. And that's what this looks like right up here. So we have all of our CIF files going down, our structure, and our formulas. Obviously, it won't get read in. You can see they're very cohesive, very nice. We have quite a bit of features here. So now that's all set. We head over to extra Excel, CSV files. We had, where am I? So I'll toss this in right here. You can see that the labeling in terms of the files is very simple, right? It just tells you the option that you did, as well as the name of the original folder. So I'll run this, and this is going to be much quicker than before. And that's already done. Again, same sort of process. We open that up. And now we run PLSDA, support vector machine, and XGBoost. So we could open up a couple of things here. Feature importance, number of feature analysis, as well as the report. So the report's right here. It'll tell you pretty much for the clustering of our potassium 2 uranium fluoride 6 type, it's probably done the best here. I don't know what support means, however, so keep that in mind. And our lanthanum iron 4 phosphorus 12 structure is probably a little bit more trickier to distinguish when just working it all out here. But all in all, pretty nice values, if I say so myself. We also get feature importance for each of the components that comprise our PLSDA, because obviously that's dimensional reduction. So we have everything out here. Depending on how interpretable you want it to be, we could get you there. As well as the number of components, how the accuracy gets better and better, and that's expected. So we have the same sort of thing going on for the rest, but let me just show you our PLSDA plot. You can see quite nice clustering, very good separation with the exception of these outliers here. But again, tells you it works, and it's a nice little visual aid. Also do the same for support vector machine. All the scores for each structure type, as well as XGBoost. So we have a nice little plot, very interpretable. Scientists could get their insights that they want to get or confirm their underlying suspicions. We see that the Wyckoff R sites, the total number of those is going to be the most important. The index is going to be the second, followed by the Wyckoff X multiplicity total, and then our interatomic distances between the rare earth and the metal sites, respectively, with the remainder being quite low. And same as before, we have the report here. This is all very nice across all of our 3 models. And we could see our run, make sure that it's all here. That's good. And that's pretty much it. So we tried to streamline this as best as possible. We know that there's still going to be a little bit of confusion and a little bit of doubts. So we are relying on the users here to provide us with valuable comments, valuable feedback and critique, because ultimately at the end of the day, we want to make sure this is widely usable as well as easily used for a variety of different things, and for the solid state community as a whole. So again, please feel free to leave comments, whatever, reach out, and that should be all. So we'll see you in the next video.